So we've covered how to take the derivative of logarithms. We know the rule is du over u if you have the natural log of u. But then the math geniuses locked away in the tower, forced to write textbooks, write questions like this one. Oh my. So this is the natural log of that monstrosity. So here's the bad news. If we just do this as it is, taking the derivative of that inside is going to require the product rule, because we're multiplying two things in the numerator, the quotient rule, because we're dividing that numerator by x, and the chain rule, because both pieces in the numerator have exponents or roots or radicals involved with them. So this would take probably about 5 different slides to work this out. So that's the bad news. Here's the good news. We can avoid all that pain. And I don't mean by avoiding it not doing the problem at all. No, I mean there's a way to make this problem a lot easier. And we'll come back to this problem and do it, but the way to solve this problem in a much simpler way is by using the properties of logarithms. Now, if you've taken pre-calculus, you've probably done these properties before. Granted, using them with derivatives would be new to calculus, but the properties are things you may have covered before in Algebra 2 or pre-calculus. So the first two are good to remember. Natural log of 1 is equal to 0. Natural log of e is equal to 1. But honestly, the thing we're going to focus on for this lesson in calculus is really the last three. It turns out that if you're taking the natural log of two things being multiplied together, you can split that single natural log into two natural logs and add them together. So the natural log of a times b is equal to the natural log of a plus b. And then it kind of makes sense. Well, if multiplying can be changed to addition, then also, as we look at number 4, division can be changed to subtraction. So the natural log of a over b is equal to the natural log of a minus the natural log of b. And then number 5 tells us that if we have an exponent, and please note that exponent is applying only to what is on the inside. If it's applying to the whole natural log, the whole thing, we can't do this. But if there's an exponent on the inside applying just to what is on the inside of the natural log, then it can be brought out front as a coefficient, as you see right here. So let's look at an example to see how this really can make these problems simpler. Okay, this one's a little easier looking than the one we had earlier. But this says differentiate y equals the natural log of x squared times the sine of x. So without using these properties, when we were taking the derivative of x squared times sine of x, we'd have to use the product rule. But using the properties of logarithms, I can rewrite the original as the natural log of x squared plus the natural log of sine of x. So please note, I have split it from one natural log into two different natural logs. I took what was being multiplied and changed it to adding, from being multiplied inside of one natural log to being added inside of two different natural logs. Now also, if I want, I can bring this exponent, because it applies just to the x, out front and write it as a coefficient. What I really meant to say earlier, what I wanted to make sure you noticed, is I'm still writing y. I haven't taken the derivative yet. From experience, I've had plenty of people, when they're doing these derivatives, they forget to actually take the derivative. They do this expanding, which is correct and a good step, but it's not finishing the problem. All I've done so far is rewrite the original equation. Okay, so now that I've used those properties, it's a much simpler derivative to take. So the 2 just stays, and the derivative of the natural log of x is 1 over x. And then the natural log of sine x, I do the derivative of sine over sine. Now that answer's fine. One way it could be rewritten, they could just combine the 2 times 1 over x to be 2 over x. And cosine over sine is equivalent to cotangent of x. So both of these answers are correct, but I guarantee you multiple choice is probably going to write it the second way. So now let's tackle this monster we saw before. Before we tackle it, I want to make a recommendation. This does not require you do it this way. Some of you may be able to simplify or expand using the log properties in one step. If you can, that's completely fine. But what I'd recommend is, just to make sure you keep things straight and don't mix them up, is do these two properties first. Any multiplying, change to addition, any dividing, change to subtraction, do that first. And then after that, as a second step, do this property where you bring exponents out front. Again, you may, after doing a few of these, feel like you can do it all in one step, and if so, that's great. But I'd recommend, just for safety, doing it in two different steps. So here, I'm going to split it into three different logarithms because I have three pieces. I have 2x minus 1 cubed, the square root of 2x to the fourth plus 1, and the x in the denominator. So first, I'll do the natural log of 2x minus 1 cubed. Then I'm multiplying that by the square root of 2x to the fourth plus 1. And I'm going to go ahead and rewrite that square root as an exponent of 1/2. So those two that were on top were being multiplied. I split them up into two different logarithms by adding them. I'm also dividing by that natural log of x because all this is inside the natural log, so I'll subtract the natural log of x. You can basically just remember that any piece that is in the numerator has a positive sign in front. Understood positive sign out here, plus, and then we have a negative sign in front of whatever's in the denominator. So I've used properties 3 and 4 the way I wrote them. Now I'm going to use the next property, and I'm still in the original function. Should have written that here. This is still y equals. And I'm going to bring the exponents out front. There we go. Alright. Now we've finally expanded it all using the properties of logarithms. So we can take the derivative. Because up to this point I've just rewritten the original problem. Now I'm ready for the derivative. The 3 stays, and I do the derivative of the inside over the inside. The 1/2 stays, and I do the derivative of the inside over the inside. And the natural log of x is 1 over x when we take the derivative, because the derivative of x is 1, and then you put it over the x. Okay, again, this answer is correct, but they will likely simplify it by combining the coefficients. So 3 times the 2 gives us 6 over 2x minus 1. And then 1/2 times the 8 is 4x cubed over 2x to the fourth plus 1. And then minus 1 over x. Now I admit, that still took some writing. That took like 5 lines of work, which isn't tiny, but I assure you it's much, much shorter and quicker than if we had to do the product, the quotient, and the chain rule all in the same problem. Okay, just one more example. What I'd encourage you to do if you're watching this is actually pause it right now, see if you can do it, and then you can hit play and see how I do it and make sure you're in the right. So again, our first step is to use the properties to expand this. I have 3 pieces again. I have the x squared, so I'll do the natural log of x squared. Then I'm multiplying the square root of 5x plus 1, which I'm going to go ahead and rewrite as an exponent of 1/2. And I'm dividing 3x minus 2 cubed. And just like before, now that I've changed all the multiplying to adding and the division to subtracting, I'm going to bring the exponents out front as coefficients. Sorry, that should be a 2. Because yes, that took me 2 lines of work, but that makes the derivative so much simpler. So now we are ready for the derivative. We do 2 times 1 over x plus 1/2 times 5 over 5x plus 1. Just for each of these, I'm doing the derivative of the inside over the inside. 3 times the derivative of the inside over the inside, and I have my answer. Like I said, they'd probably simplify and combine the coefficients that were out front. So write this as 2 over x, and then 5 times 1/2 isn't a whole number, so they'd probably just do 1 times 5 on top, and then distribute the 2 to the 5x plus 1 on the bottom. Then 3 times 3 is 9. So this is likely how you'd see the answer on a test. Alright, good luck. So that's how to take the derivative of logarithms using the properties of logarithms.